Hey guys, we're doing notes 2.5 today, and this is going to be rational exponents. So you kind of know some of this already. I always tell you that at the beginning, but it's true. A lot of these rules come from Algebra 1. So you kind of know a little bit of every lesson for Algebra 2 before we do it. So this one is showing you the link between radical expressions, which we did in 2.4, and rational exponents. There is a link between them. So if you notice right here, I have a little diagram of a radical expression and then a rational exponent. And rational just means a ratio or a fraction. So remember how last class or last lesson 2.4, we talked about how the power is divided by the index. Well, if you were to write that power divided by that index as a fraction, this is what it looks like. So it's really easy to convert between a radical expression and a rational exponent because all you're doing is you're placing the power over the index, and that's your fraction. So the first few examples are exactly that. All we're doing is we're learning how to convert from one to the other. I'll make this a little bigger. There we go. So for example 1, convert from exponent to radical. And of course, these things are not going to stay super easy. They're going to get a little more difficult, and they're going to require skills that you learned even in like grade school or middle school. So right here, x to the 3/7 or x to the 3/7. Remember the that from here that your power basically becomes the numerator and your index is the denominator. So if you can remember that the index is the denominator, that's pretty much all you need. The base stays the same, the base doesn't change. So your index is your denominator. So if I do that, then if I keep track of that rule, then what I have here is a base of x with an index of 7 and a power of 3. So that becomes the 7th root of x to the 3rd. The 7th root of x to the 3rd. And that's pretty much what you need. That's the only thing you need to do to convert from one to the other. If you can convert from exponent to radical, you can also convert from radical to exponent. So that's the answer for that one. So when you look at the second one, a b right here, right? When you look at b, you notice that there is a negative that we're not supposed to have there. We're supposed to simplify this all the way. Let me make it a little bigger. There we go. You have a negative and you have a fraction. So from grade school, I don't remember when it is that you learned how to turn fractions, decimals into fractions, but from grade school, remember, if you have 3.5 and you want to change that to a fraction, you're going to have to move that decimal until it's behind the first number, the first digit on the right. So that becomes 35. Because you moved it once, then you have to divide by 10. It's always base of 10. So if you move the decimal twice, then you have to divide over 100, 3 times over 1,000, and so on and so forth. So then this becomes y to the negative 35. Oh, sorry, I forgot to tell you that you have to reduce it. I'm forgetting regular things here, guys. Sorry about that. So 35 over 10 reduce. You can reduce both by 5. Right? If I reduce 35 by 5, I get 7, and 10 by 5, I get 2. So it becomes y to the negative 7 over 2 power, right? Or y to the negative 7 over 2 divided by 2, or 7/2. But it's negative, so we have another problem. This is where the rules of exponents apply, just like they apply to radicals, they apply to rational exponents. So because we have a negative, we have to use the reciprocal of that. And then another rule you learn, right? Having a rational exponent in the denominator is exactly the same thing as having a radical in the denominator. So you have to think in terms of getting rid of the y to the 7/2. That's the same thing as having the square root of y to the 7th, right? So if you think about what to multiply by so that you can actually make the numerator divisible by the denominator, you would be adding the exponent because you have a base of y. So if I multiply by y to the 1/2, right? Remember, you got to do it top and bottom. But if I multiply, what I'm really doing is adding the exponents. So 7/2 plus 1/2 is 8 over 2, or 8/2. That gives you 4. So that gets rid of the denominator, rational exponent in the denominator. So that gives you y to the 4th on the bottom. On the top, you basically have 1 times y to the 1/2. So that gives you y to the 1/2. But remember that the instructions were telling you to convert from exponent to radical. So the last part of this is to take this and change it to radical form. Any base to the 1/2 becomes a square root. So this is basically square root of y over y to the 4th. There we go. And that's your final answer for that one. Just dropped my pen. Sorry, guys. All right, so on the other side, take a little time, pause the video, do it on your own, and then come back and check it. So we have a problem with the negative, the first issue we see. So we're going to take care of that by just using the reciprocal. So remember, any base is over 1. So when you use the reciprocal, you're flipping or reflecting that base, not the power. The power stays the same. The power, the only thing that's going to happen is that it's going to lose the base. So this becomes 1 over w to the 5/8. Notice I did not flip the 5/8. The negative 5/8 just becomes positive 5/8. And then we have to think in terms of the, like the one we did before. So I need a number divisible by 8 higher than 5. That would be 8. So if I multiply by w to the 3/8, when I add these two fractions, 5/8 and 3/8, I'm going to end up with 8 over 8. So I'm going to lose the whole fraction. And you got to do the same thing in the numerator. So this becomes w to the 3/8 over w, because when you add the 5 and the 3, 8 divided by 8 is 1. Now, we got to change this to radical. Remember that the index is always your denominator. So that's the 8th root of w to the 3rd, and make sure you learn how to read it correctly, over w. There's no square root, 8 root, like some of you guys read it. It's the 8th root, the index first, 8th root of w to the 3rd power over w, and that's your final answer. So for this second one, for D on your side, you have a decimal. So same thing. If I have 0.2 or 0.2, I'm going to have to move that decimal once. That gives me 2 over 10. Since I moved it once, I put it over 10. That's going to be divisible by 2. So you're going to end up with 1 over 5. So what you have is really w to the 1/5. And this one, since all we're doing is changing it to radical form, all we got to do is use the index of 5, right? So this is the 5th root of w, and that's the answer for that one. I don't need to write w to the first. All right, so in the next couple of examples, we're converting the opposite way. We're going from radical to exponent. So it's given to you in radical form. All you have to do is remember that the index is your denominator. That's it. So this becomes a to the 5/2. All we're doing is converting. For this one down here, the 5th root of b inside parentheses with a power of 3 is the same thing as the 3 being applied to any base on the inside. So this becomes the 5th root of b to the 3rd. And very simple, your index is always your denominator. So 5 is the denominator. So that becomes b. Oops. No, what's wrong with my pen? My pen stopped working, guys. I need a new one, I guess. Read to the b to the 3/5. Ay, ay, ay. All right, very simple, very easy. It's gonna get a little more difficult, so don't hang your hat just yet. This becomes x to the 3/4. This is the same as the 5th root of y to the 4th, so it becomes y to the 4/5. And I don't know why I have a normal y and a fancy y. It's just it comes out like that sometimes. All right, so that's the conversion part. The next part we're going to do is simplifying. So with simplifying, I don't want you to necessarily have to turn everything to radical or everything to exponent. It's just sometimes it's easier to work with one or the other. But I want you to think in terms of which is the index and which is the power without having to convert all the time. So for example, if we're looking at 216 to the 1/3, we know the 3 denominator is the index. So that's the equivalent of the cube root of 216. The cube root of 216 is 6. And then you have to bring it to a power of 1. And that gives you 6. So notice we didn't have to do this. So this is what I don't want you to do. I don't want you to have to convert 216 to the 1/3 into the cube root of 216 to the first. And then think cube root of 216 is 6. And then bring it to the first power. I want you to think about what the numbers mean so that it can stick more to you. So the number on the bottom is always going to be your index. You generally do that one first because that one is going to reduce the base. And it's always easier to work with a smaller number than with a bigger number. Could you do the power first? Absolutely, but that's going to make your number bigger. Bigger is harder to work with, especially if you're working without a calculator. So think of the number on the bottom first. That number will reduce your base because that's an index. So cube root of 216 is 6, and then you bring it to whatever numerator or power you have, and that's 6 to the first in this case. So that's just 6. So I want you to think for this one in terms of the property. This is a multiplication problem. Think of the properties. The properties of exponents say that if you have the same base, which we do, right? We keep that base, and because we're multiplying, we're adding the exponents. So you're keeping the base one time. Nothing happens to the base. You don't multiply 7 times 7. The base stays. That's a property that makes your work easier. So that becomes 1/2 plus 1/2 is 1. That's 7 to the first. So that's just. And remember, a power of 1, you don't have to write it. I write it as I go so that you know what number is there, but at the end, the final answer, you don't need it. All right, so look at C. And C, we're multiplying 5 to the 1/4 times 125 to the 1/4. So the problem with this one is we don't have the same base. So we're going to try to get the bases to be the same. So the 5 to the 1/4, I'm going to keep it the same way I have it. But I'm going to try to turn the 125, right? The 125 itself into a base of 5. So can we get 125 to be 5 to the something power? Is that equivalent to 5 to the something? Well, 5 to the third is 125. So I'm just going to turn the 125 into 5 to the third. Now, that's just this base, right? There's still a power of 1/4 right here. So that goes out here. And remember, you're using properties of exponents. These are exponents. They just happen to be fractions, but the rules are the same. Rules of exponents are the same no matter what type of numbers you have. So power of a power, you're multiplying. So now that becomes 5 to the 1/4 times 5 to the 3 times 1/4 is 3 over 4. 5 to the 3 over 4. And then we can use the powers of exponents that say that if you're multiplying the same base, which you now have, you can add the exponent. So keep the base one time, and you're adding 1/4 plus 3/4, and 1/4 plus 3/4 is 1. So that gives you 5. 5 to the first or 5. So go ahead and pause. Get these done on your own paper and then play again to see if you got it right. So 64 to the 1/2, that means the square root of 64, which is 8 to the power of 1. So that's just 8. And this one's going to be a piece of cake because you already did the same one with 7. I'm giving you easy ones at the beginning so you get the hang of practicing the properties again, but they're going to get a little more difficult later on. So 11 to the 1/2 times 11 to the 1/2, same base. Since I'm multiplying, I can add the exponents, keep the base. You do not multiply the base. You keep the base, you add the exponents. That becomes 11 to the first, and that's just 11. So now when we get to the last one, this last one becomes a little more difficult because 12 doesn't have a square root, right? And remember, the index is the bottom or the denominator. And it's not a perfect square. So we can't really turn 12 into a base to the something power to get that number. It doesn't work. So the second best thing we can do is split the number. So the same way that we split in the previous lesson, square root of 12 into square root of 4 times square root of 3, we can split this into 3 to the 1/2 times 4 to the 1/2. So look what happens when you do that. You have a 3 to the 1/2 in the front. Instead of 12 to the 1/2, I'm going to split the 12 into 4. Let me do the 3 first. It really doesn't matter, but I just visually I need to organize it. So 3 to the 1/2 times 4 to the 1/2, right? 3 to the 1/2 times 4 to the 1/2 is the same as square root of 3 times square root of 4. And when you multiply that, you get square root of 12, which is what this is. So why do we want to do that? Well, at least we got the same base here. If we have the same base, we can use the properties of exponents that say keep the base, and because you're multiplying, add the exponents. So you end up with just 3. So this mess up here, this holy mess that we made up here, that's just 3. And then now look at this, how convenient this is. If the denominator is the index, this is the square root of 4. The square root of 4 is 2, right? 2 to the first power is just 2. So you end up multiplying 3 times 2, which is just 6. Would it work the same if you change it to radical form? It would, but I don't want you to have that crutch of having to change everything to another format to work with it. Sometimes it's easier to work it in exponential form. Sometimes it's easier in radical form. All right, so let's talk about the simplifying part right here. So this is, oh, we're done with simplifying, sorry. This is multiplying and dividing. Remember, I leave multiplying and dividing for last. Multiplying is pretty easy, but dividing always gets a little more difficult. So we have multiplying and dividing examples next. This is the fourth root of x to the third divided by the eighth root of x to the second. So remember the properties. We can't really work with two radicals that have a different index, right? So what we want to do is turn each one into rational exponent form. Remember the index is your denominator. So this becomes x to the 3/4 divided by x to the 2/8, right? And 2/8, I want you to think ahead a little bit before you do the next step. 2/8, we can divide that. We can reduce that to 1/4. And we do have the same base. Since this is division, we're going to end up subtracting, keeping the base and subtracting the exponents. So change that to 1/4, reduce it to 1/4, or 1/4. And then you can use the property that says division is the same as subtraction for exponents. So x to the 3/4 over x to the 1/4 becomes x to the 3/4 minus 1/4. So then 3/4 minus 1/4 is going to give you 2/4. And that's going to give you 1/2 when you reduce. And the last thing is, since this doesn't really tell you in what format to keep your answer, your final answer, or to express your final answer, go back and take a look at the original. If the original was given to you in radical form, change it back to radical form. If it was given to you in exponential, change it to exponential. So this right here, x to the 1/2, remember any base to the 1/2 is a square root. So that's basically square root of x. And that's your final answer for that one. So that's using variables. Here's the property using regular numbers or constants. So we can't really multiply these two radicals. Let's see if you remember why from the last lesson. 2.4. What's the rule for multiplying radical expressions? You need the same index. So the radicand can be the same or not the same, but the index has to be the same. We can't really work these out the way we have it because we have an index of 4 here, we have an index of 2 here. So in this case, we have to change it to rational exponent form. So this becomes 3 to the 1/2 times 3 to the 4, sorry, to the 1/4, not to the 4, we're 1/4. That doesn't exist, by the way. It's just 4. So this is 3 to the 1/4. Remember that if you don't see a power would be 1. So there's really a power of 1 here. If you don't see an index, the index is 2. That's why this one turns to 3 to the 1/2 and 3 to the 1/4. Now here's the problem. We have the same base, right? We can work with the same base, but we don't have the same denominator. If you multiply bases, you're keeping the base, but you're adding exponents, right? Your exponents happen to be fractions. We can't really add fractions when the denominators are not the same. So this goes back to grade school when you learn how to deal with fractions. We need the same denominator for the fractions. So if I just take the first one and multiply by 2, the whole fraction obviously by 2, then we're going to end up with 2/4. So this becomes 3 to the 2/4 plus 1/4. And that's going to give you 3 to the 3/4. Now remember the answer was in radical form. When we turn this to radical form, we have 4, the fourth root of 3 to the third. And because this is just a constant, that can be expanded. So we can actually simplify 3 to the third. So that becomes the 4/4 of 3 times 3 times 3, or 3 to the third, is 27. There's your answer for that one. And remember, pause, work on these two on your own, and then play again to see if you got it. So I'm going to work with these two. This is x to the 3/2 over x to the 2/3. So same base, I'm dividing, so I'm going to subtract. Keep the base and subtract exponents. Remember, for subtraction, it's always the top one minus the bottom one, always. That doesn't change. So 3/2 minus, did I say that right? Yes, 3/2 minus 2/3. The dyslexia is going to kick in because these numbers look very similar. So we don't have the same denominator. We got to multiply the first one by 3, the second one by 2, so we can get 6 as a denominator. So I have x. I know my denominator is going to be 6. So I can write it like I did here with two fractions in the previous examples, or I can write it as the sum or subtraction, sum or difference of two numbers on the top and keep the same denominator, because the denominator is not going to change. This is 3 times 3, that's 9, minus, this is 2 times 2, that's 4. So this becomes x to the 9 minus 4, that's 5 over 6. And that's your answer for that one. Now, because we were given the question in radical form, we should go ahead and change it to radical form. So it's the 6th root of x to the 5th power. And that's the answer there. And the second one, D, you're working with regular bases, but remember the rules don't change just because your base is a variable or a regular number, a constant. It's the same. So the first one is 7 to the 1/2. The second one is 7 to the 1/3. And again, I need the same denominator. I can use the properties because my base is the same, but I gotta work with the fraction with the denominator. So I'm gonna keep the 7 because I'm multiplying. I'm gonna add exponents, but I need this one times 3 and this one times 2 to make sure I have the same denominator of 6. So then 1 times 3 is 3 plus, right? Because you're multiplying the bases, so you're adding the exponents. 1 times 2 is 2. That gives you 7 to the 5 over 6 or 5/6 power. Then you can change that to radical form. So that's the 6th root of 7 to the 5th, and you can expand 7 to the 5th. So 7 to the 5th becomes the 6th root of 16,807. And in radical form, it was given to us like that. We can leave it in radical form. There we go. So if it's 16,807 is not a perfect 6th root, you leave it alone. All right, so let's talk about reducing bases when you're just working with real numbers. So to me, this is probably the easiest part of these notes because you can do this with your calculator and you don't have any variables. So you don't have to think about the variables. But you do have a couple of issues here. You have a regular constant base that has a power that's not only a negative, but also a decimal. We know how to fix the negative. We're going to do the reciprocal of 16 over 1. We'll do that in a second. But we also have to fix the decimal. We'll do both on the same step. So 2.5, we're going to move this once. That becomes 25 over 10, because I moved it once. That becomes 5/2. That looks horrible, guys. Hold on. Let me see if I can do this right. 5 over 2, or 5/2. So if I'm going to change the 2.5 to 5 over 2, but I'm also going to flip the fraction or do the reciprocal, right? Do the reciprocal of the fraction. So that becomes 1 over 16 to the 5/2. And remember, I don't want you to use the crutch of having to turn everything to radical. We know we can expand this. We can simplify this. Always look at the denominator first because that's your index. That's going to make your base of 16 smaller. So square root of 16, that's just 4. So it becomes 1 over 4 to the 5th power. And now I have to expand that 5th power. So that becomes 1 over 1,024. And we don't have to worry about variables on these. So some of them will have variables, some of them will not. So this one, negative 32 to the 4/5 power. There's nothing we have to flip here. So be careful because some of you see a negative and immediately you flip stuff. The negative can have, the base can be negative. What cannot be negative is your power. So this doesn't require any reciprocals here. This is a negative base, not a negative power. So you're good here. So think about the 5th root of negative 32. The 5th root of negative 32 is negative 2. Now bring that negative 2 to the 4th power. That gives you 16. Be careful when you enter this in your calculator. Some calculators, when you enter this without parentheses, they recognize that you're trying to bring a negative base to a positive power or an even power, and it gives you the correct answer. Some calculators, if you don't write these parentheses or input these parentheses in there, it'll take only the base of 2. It'll leave the negative out, take a base of 2, bring it to an even power, and then keep the negative, which is the wrong answer. So be careful when you enter that in the calculator. As a rule, a negative base to an even power will always give you a positive answer. A negative base to an odd power will give you a negative answer. So keep that as a rule as well. All right, so you know what time it is. You gotta pause, do this on your own paper, and then come back and check to see if you did it right. I'm gonna go ahead and keep going. So 4th root of 16. I'm always going to focus on that rational exponent on the bottom, on the denominator. 4th root of 16 is 2. If you bring 2 to the 3rd power, you get 8. And that is your answer for that one. Simple. Now, 9 to the negative 3.5, we know we have to flip it. So eventually, and that's why I put the little 1 underneath the base to remind me that I am flipping that base. So the 3.5, remember, we're going to change it to fraction. That becomes 35 over 10. And if I reduce by 5, that becomes 7 over 2. So that's the equivalent of 1 over 9 to the 7 halves. So I did the flipping over already, and I did the changing the decimal to fraction. So now we're going to reduce the bottom or simplify the bottom. Square root of 9. The square root of 9 is 3. So that becomes 1 over 3 to the 7th power. And 3 to the 7th power is 1,187. And that's your answer there. All right, guys, so we've made it to example 6, the last one. And the last one is going to throw all of the properties at you at once. Maybe not all of them, but it'll throw a couple of them together. So you can really use the properties in any order you want as long as you understand how to manipulate them. So simplifying using multiple properties, it says to write each expression in simplest form. It doesn't tell you what format to leave it. So first thing, notice that we do have a fraction as an exponent inside parentheses, and then there's another exponent. So power of a power is multiplication. So you can multiply first and then flip the fraction over, or you can flip it first and then multiply. So I like the multiplying first because it usually reduces what you have inside the parentheses. So if you notice, 2/3 times negative 3, the 3 and the 3 cancel. So you end up with x to the negative 2. Or think about multiplying 2 times negative 3, that's negative 6, divided by 3, that's negative 2. And now the only thing I have to worry about is, flipping that base over. So that becomes 1 over x squared. And we're okay with an exponent in the denominator. We're not okay with a rational exponent in the denominator. So no negatives, no rational exponents. That's your final answer for that one. Okay, when we take a look at this one, be very careful because students take a look at negative 27x to the negative 9 and the whole thing to the 1/3. So essentially it's the same rule as we just did. It's power of a power. But you tend to forget that negative 27 is if it's its own base and it has a power of 1. Power of a power means multiply not the base by the power, but the power times the power. So this becomes negative 27 to the 1/3 and x to the negative 9 times 1/3, that becomes negative 3, x to the negative 3, right? So then we have two different things here. We have the constant base and we have the variable base. The constant base, think about, notice that there's no problem here. We don't have an issue here. The base is what's negative here, not the power. So this is just negative 27 to the 1/3. That's the cube root of negative 27, right? Is an even index, an odd index of a negative base, that's going to be a negative. So that becomes negative 3 to the first power. Negative 3 to the first power is just negative 3. Now this one here, the base of x, this one we have to flip over. So then that becomes 1 over x to the 3rd. So negative 3 times 1 over x to the 3rd is just negative 3 over x to the 3rd. And that's your answer for that one. So we're using all of the properties or some of the properties, multiple properties in the same problem. So work on these on your own. Remember, you can flip over first and then do your power of power, or you can do your power of power and then flip over. Whichever way you want to do it will work the same as long as you know how to manipulate the properties. So on this one, I think I'm going to, what do I want to do with this one? I'm going to just apply the power. So that becomes 3 to the negative 1 times x to the negative 2/3. So they're both negative. I have to flip both over. So this becomes 1 over 3 to the first, and 3 to the first is just 3. And this becomes x 1 over x to the 2/3. So then we just have to take care of the 2/3 here, right? The 3 is fine. There's nothing wrong with the 3. We got to take care of this. Can't have a fractional exponent in the denominator. We got to multiply times x to the 1/3 because we're going to end up adding that and it's going to give us 3 to the 3rd. 3 over 3. So it'll cancel to 1. So we have x to the 1/3 over 3x. And that's the final answer for that one. Hold on. Here we go. Last one. So we can multiply this in here. So you got x to the -3, y to the positive 12. Be careful with this one. Positive 12 over 3 is y to the 4th. So you end up with y to the 4th over x to the 3rd because that's the only one that you have to flip over. All right, guys, that's it for this one. So I'll see you on the next one. Have a great day, everybody.